to discuss about the spectra. What is the spectra? When the radiant energy passed through the prism, it can split into different directions as a series of lines. Okay, for example, this is radiant energy. Radiant energy passed through the prism. For suppose we are assuming this is prism. Passed through the prism, it can split into different directions as a series of lines. As a series of lines is called spectra. Okay, next another term in the spectrum, dispersion. What is the dispersion? When the white color split into 7 colors as a web geode. Okay, white color split into a 7 colors. 7 colors as a web geode. How many colors? 7 colors. 7 colors. So what are the 7 colors? Violet, indigo, blue, this is green, yellow, orange, red. So white color split into 7 colors as a web geode. That is called dispersion. Next, another one, spectrometer. Spectrometer means it is the device which is used to record the spectrum on screen. Which is the device used to record the spectra on screen. That is called spectrometer. So we have to use spectrometer so we can able to see the spectra on screen. So spectra visible in this device. That is called spectrometer. Then types of spectra. Generally spectra two types. Continuous spectrum, discontinuous spectrum. What is the continuous spectrum? Continuous spectrum means when the one color merge means combine. When the one color merge with another color, there is no gap. Between two colors. After merging, we can't identify previous parent colors. After mixing two colors, we can't identification separately. Okay, both are completely mixing. There is no gap between two colors. That is called continuous spectrum. Okay, when the one color merge with another color, there is no gap. That is called continuous spectrum. Best example, sunlight. So sunlight has 7 colors, 5G or, but we cannot determination separately each color. All 7 colors mixing visible as a white color. Already regular life knows about sunlight. Okay, we count determination separately. That is called continuous spectrum. Then discontinuous spectrum. Discontinuous spectrum. When the one color merge means combine. When the one color merge with another color, there is gap. There is gap. That means after mixing of color also, we have easily determination or easily we can separate of individual colors. Okay, easily find out individually separate colors or parent colors. So that's why discontinuous spectrum means when the one color combined with another color, there is a gap. In this spectrum, we can easily identification one color from one color to another. After merging also, we can easily identification one color to another color. That is discontinuous spectrum. So here gap is there. Gap is there. That's why we can easily identification. This is distinct. Distinct means we can easily separate from one to another. We can easily differentiate from one to another. That is called distinct. Generally, many examples for discontinuous spectrum. So nowadays, regular life, all colors examples to discontinuous spectrum. Then again, discontinuous spectrum, two types. Again, discontinuous spectrum. Discontinuous spectrum, two types. That is absorption spectrum. Absorption spectrum. Then second one, emission spectrum. Absorption spectrum, emission spectrum. Okay, what is the absorption spectrum? This spectrum produced by observe of radiation energy, accepting. Observe means accepting. So this spectrum produced by absorption of radiation energy. Observe of radiation energy. That is called absorption spectrum. Here important point. In absorption spectrum, dark lines on when we observe absorption spectrum, dark lines on bright background. Dark lines on bright background. Right? Background. Okay. Next, another very important point in absorption spectrum. Absorption spectrum is producing due to excitation of electrons. What is the meaning of excitation? Electrons moving from lower state to higher state. Electrons are jumping from lower energy state to higher energy state. That is called excitation. So absorption spectrum produced by excitation of electrons. Excitation of electrons. Okay, absorption spectrum produced by excitation of electrons. Examples here for absorption spectrum. Examples, for example, lamp is the best example for absorption spectrum. Next one, emission spectrum. What is the emission spectrum? Absorption spectrum means when the radiation energy is observing. Emission spectrum means this spectra produced by release of radiation energy. Emission spectrum means this spectrum produced by release of radiant energy or release of radiation energy. So it is produced by release of radiant energy. Release of radiant energy. Okay, that is emission spectrum. Next, in absorption spectrum, if you observe dark lines on bright background, here bright lines on here, bright lines on dark background, bright lines on dark background. Okay, in emission spectrum, bright lines on dark background. Next, absorption spectrum produced by due to excitation of electrons, but emission spectrum produced by due to de-excitation of electrons. De-excitation of electrons. Okay, what I say? Excitation means electrons jump from lower energy to higher energy. De-excitation means electrons moving or jump from higher energy state to lower energy state. De-excitation means electrons jump from higher energy state to lower energy state. So this is about the absorption spectrum and emission spectrum. Then emission spectrum, two types. Then emission spectrum, two types. Line spectrum, this is also called atomic spectrum. Light spectrum and band spectrum, this is also called molecular spectrum. Molecular spectrum. So again, emission spectrum has two types: line spectrum, band spectrum. Line spectrum also called atomic spectrum, band spectrum also called molecular spectrum. So what is the light spectrum? This is generally produced in atoms only. That's why it is called atomic spectrum. Atoms. Next, in light spectrum, if we observe on spectrometer, one line easily separate from another line. That means one line it can easily distinct from another line. Easily distinct means easily we have to separate from another line, while visibility easily separating from one line to another line. That's why, so here thick lines come. Like that come. Thick lines. So one line easily distinct from another one. That's why line spectral lines are distinct lines. Distinct means one line easily separate from another line. And sharp lines, thickness, sharp lines, distinct lines and sharp lines. means close lines. Close lines. That means like that. Very close lines. So some things when we observe packed, unpacked, barcode is there. When you purchase some things unpacked, so we have observed barcode like that. So that is the closed lines. Here no sharpness of the lines. Here no distinct. No distinct means we could not one line separate from another line. That is the closed lines. Examples: hot metals, and all type of molecules. This is about light spectrum and band spectrum. In your NEET syllabus, they given light spectrum of hydrogen atom or atomic spectrum of hydrogen atom. Okay. Light spectrum of hydrogen atom or atomic spectrum of hydrogen atom. So, if we observe on spectrometer, hydrogen spectrum split as a 6 series of lines. The series of lines are Lehman series, Balmer series, Pascal series, Brocket series, Fund series, Ampere series. Not in your syllabus, but 6th series also there. Ampere series. Generally, your syllabus, NEET syllabus, you have to read about 5 series of lines. So, hydrogen spectrum, if you observe in spectrometer or if you observe on screen, we have 5 series of lines. 5 series of lines. That is Lehman, Balmer, Pascal, Brocket, and Fund. 6th one also there Ampere, but not in your syllabus. Major, you have to read these 5 series of lines: Lehman, Balmer, Pascal, Brocket, and Fund. So 5 series of lines we should read. Just see that. Right. First series, Lehman. It visible in UV region. First transition state N1. N1 means first transition state or first energy level. So already 10th class you read in Bohr's theory. First energy level K, N1 equal to 1, L, N1 equal to, like that. So N1 equal to 1, first energy level, N1 equal to 1, N2 equal to 2, 3, 4, so on. Second one, Balmer. It can visible in visible region, okay, visible region, yeah, n1 equal to 2, n2 equal to 3, 4, 5, so on. Next, third one, Pascal, it can visible in near IR region. IR means infrared. IR means infrared. Near IR region. N1 equal to 3, N2 equal to 4, 5, 6, so on. Next, bracket series. This is IR region midway. This is near, this is somewhat midway. IR region. Okay, here N1 equal to 4, N2 equal to 5, 6, 7, so on. Next, fund series for IR region. N1 equal to 5, N2 equal to 6, 7, 8, so on. This is about the in hydrogen spectrum 5 series of lines. Lyman, N1 value should be important amount. Lyman series, N1 equal to 1. It can appear in UV region. Balmer, N1 equal to 2. It can appear in visible region. Pascal, N1 equal to 3. It can appear in near IR region. IR means infrared. Bracket, N1 equal to 4. It appear in infrared region. Fund, for IR region, N1 equal to 5. So N2 value more than one value than N1 values. So this is the 5 series of lines in hydrogen spectrum. First one, Lyman. Second one, Balmer. Pascal. Bracket. Fund. Okay, how does transitions takes place? Lyman transition. Balmer to Lyman. Then Pascal. In Pascal inside, next Pascal to Balmer. Pascal to Lyman. Bracket. Inside the bracket. Bracket to Pascal. Bracket to Balmer. Bracket to Lyman. Next fund. Fund to bracket. Fund to Pascal. Fund to Balmer. Fund to Lyman. So like this, transition takes place from one series to another series. Here, which series more lines giving, more transition giving? Fund. Next to bracket. Next to Pascal. Next to Balmer. Next to Lyman. That means number of series lines given by fund. So in fund inside one line, fund to bracket one line, fund to Pascal, fund to Balmer, fund to Lyman. Like that, bracket, Pascal, Balmer, Lyman, like that only. That's why this is the way of transitions between the series. Okay. Next one. some calculations in spectrum. First, we should know the terminology. We should know the terminology. Right. Initial line, if terminology comes, starting line, initial line, starting line comes means wavelength maximum, remember, frequency minimum, frequency minimum. Next, last line, okay, last line or end line means wavelength minimum, frequency maximum, frequency maximum. Okay, so some concepts, that means theoretical questions come in NEET exam. That's why sometimes direct question asking. So any series, initial line, starting line given means wavelength maximum, frequency minimum. This terminology means last line, end line means wavelength minimum, frequency maximum. Okay, next one. If they given short wavelength, for suppose they giving short wavelength giving. Okay, some are problems. Short wavelength term come means N1 equal to particular series value, N2 should be infinity, N2 should be infinity. Okay, for suppose examples, Lehman giving for short wavelength, N1 equal to 1, N2 equal to infinity. For suppose Balmer giving N1 equal to 2, N2 equal to infinity. For suppose Pascal giving N1 equal to 3, N2 equal to infinity. Bracket N1 equal to 4, N2 equal to infinity. Font N1 equal to 5, N2 equal to infinity. Okay, this is way of application. Okay, when the short wavelength given in sums, you can apply like that. Next one. For suppose first line of any series, they given. For suppose first line of any series, okay, that we assume to equal to alpha. First line of any series we call alpha. Second line of any series, we call beta. Third line of any series, gamma, we call it gamma. first line of any series we called alpha, second line of any series we called beta, third line of any series we call gamma. Now it is applied to Balmer series. Important. Your syllabus Balmer series is very very important. Okay. So Balmer series, what region? Visible region. Balmer series, visible region. What is the N1 value? 2. Right. First line of Balmer. First line of Balmer. First line of Balmer. This is called alpha. This is called alpha. N1 equal to 2, N2 equal to 3. Fixed values. First line of Balmer series means N1 equal to N1 fixed value, no problem. N2 equal to 3. First line of Balmer series they giving means N2 equal to 3. Next. Second line of Balmer series. Second line. This is called beta. Beta. N1 value fixed. Any line of the Balmer series, N1 value constant. Any line of the Balmer series, N1 value constant. That's why N1 equal to 2, N2 equal to 4. N2 equal to 4. Next. Third line. Third line of the Balmer series. So N1 equal to fixed value, N2 equal to 5. N2 equal to 5. This is about first line of Balmer means N2 equal to 3. Second line of Balmer means N2 equal to 4. Third line of Balmer means N2 equal to 5. N2 equal to 5. Then next one, maximum wavelength. Maximum wavelength. Maximum wavelength. They given sums. Maximum wavelength or long wavelength. Long wavelength. In problems, if they given maximum wavelength or long wavelength means N1 equal to particular series, N2 equal to N1 plus 1. N2 equal to N1 plus 1. For suppose, examples, Lehman. For suppose, they given for Lehman series, maximum wavelength or long wavelength. N1 equal to 1, N2 equal to N1 plus 1, 1 plus 1 equal to 2. If they given long wavelength means indirectly they are asking them, they are not giving values. If they giving values means we can easily find out. But just they mention long wavelength or maximum wavelength they have to mention. So we only assuming particular series. For example, Lehman means N1 equal to 1 fixed value. N2 equal to N1 plus 1. 1 plus 1, 2. For suppose, Balmer. N1 equal to 2. N2 equal to 2 plus 1, 3. Okay, Pascal. N1 equal to 3. N2 equal to 3 plus 1, 4. Like that, Bracket. N1 equal to 4, N2 equal to 4 plus 1, 5. Fun. N1 equal to 5, N2 equal to 5 plus 1 equal to 6. N2 equal to 5 plus 1 equal to 6. So, like that we have to assuming. In problem, they didn't give